Welcome back to the course. In our previous class, we were trying to talk about soil exploration. What are the different methods by which we can go on to carry out the soil exploration process? And we have talked about in the process of exploring the ground. That means by making the boreholes, we are collecting the soil sample from the field from different depths, and that soil samples are used for conducting various laboratory tests for determining the different properties of the soil, which could be either index properties or engineering properties. And we have also talked about the condition like it may not be always possible for us to collect your representative soil sample for conducting the tests in the laboratory. So sometimes we will be also depending on what is called as our field tests, based on which we'll be trying to predict the condition of the soil there, the soil which is existing at different depths below the ground. So one of such field tests what we'll be coming across in today's lecture is standard penetration test. So in the case, in this particular standard penetration test, what we are going to be doing is we are going to be penetrating a sampling tube into the ground. We are going to be pushing the sampling tube into the ground by applying some standard load from top. We'll be applying what is called as an impact load on top of your sampling tube. Because of that applied impact load on the sampling tube, where that load is going to be freely falling from standard height, a standard weight falling from some standard height, which will come and hit the top of your sampling tube, because of which it's not the direct hitting on the sampling tube, rather this sampling tube is going to be connected to a connecting rod, where in turn that connecting rod is connected to what is called as a collar. Okay, on top of that collar you are going to be applying what is called as your impact load. When that impact load is applied on the collar, so due to that impact load, you will see that your connecting rod which is connected to the collar will be getting pushed in the downward direction. In turn, your so-called sampling tube, here the particular sampling tube what we are going to be using is called as split spoon sampler tube. We'll try to see all that what we are talking about. So that split spoon sampler tube in fact is getting penetrated into the ground, and depending on how many number of blows are required to be given per 1 feet depth of penetration into the soil strata, that number of blows is what we are going to calculate ultimately from the standard penetration test for 1 feet depth of penetration. So depending on that number of blows, that number of blows what we are going to calculate is what is called as standard penetration number, SPT n value. N indicates number. Okay, so depending on that SPT n value, we have got different correlations available in the literature, based on which one can go on to find out different properties of the soil. It could be the C value of the soil, it could be the phi value of the soil, or various other properties like say relative density of the soil, or we can even go on to find out the bearing capacity factors of the soil, by which you can try to determine the bearing capacity of the soil. Okay, so you have got various enormous relations, empirical relations that are available in the literature, based on which one can try to find out the various other soil properties which could not be directly determined in the laboratory. So by knowing the SPTN value, we can go on to find out those particular properties of the soil. Okay, once those properties of the soil are known, then yes, we can go on to understand the condition of the soil. Okay, so whichever you are looking at whatever depth your SPTN value for the soil is determined, then depending on that SPTN value, we can say what is the condition of the soil that we are basically looking at. Yeah, so this particular SPT test is a most commonly or widely used in situ test. Okay, so the SPT test what we are referring here is a most commonly or a widely used SPT test. More commonly or widely used field test, because we have been talking about different field tests in the previous class. So out of all that, this is the most common field test what people prefer to perform in the field. The reason for preferring this particular test is, as you have got varieties of correlations available in the literature, so it will be easy to find out your required parameter of the soil, required property of the soil based on your SPT N value. And this particular SPT test is especially preferable in the case of your cohesionless soil, that is particularly in the case of sandy soil, or maybe in the case of your silty soil deposit or gravelly soil deposit, in which we'll prefer to go for this SPT N value. This SPT test is useful in finding out the relative density of the cohesionless soil, or it will be useful in finding out the angle of shearing resistance of your cohesionless soil, and it might be useful, it can be useful in determining your unconfined compressive strength of your cohesive soil. If I say unconfined compressive strength, that means nothing but QU. So from the QU value, one can go on to find out your CU value, that is your undrained cohesion value of that your cohesive soil. So likewise, you have got various other ways, various relations by which one can go on to find out those respective properties of the soil depending on the SPT N value. So now what does this SPT test setup basically contain? Okay, so to start with, because if I am required to carry out the SPT test, first thing is I should be making a borehole into the ground till the required depth where I should be performing my SPT test. Okay, roughly let us first understand how this SPT test is performed in the field, and then we'll go ahead in understanding the step-by-step procedure of various accessories that are required for carrying out the SPT test, and then subsequently how the SPT N value is determined, and from that SPT N value, do we need to apply for that SPT N value what we have calculated? Do we need to apply any correction? If at all some corrections are required, what are those respective corrections, and so on? We'll try to understand, and then later on we'll go on to summarize in knowing what are the advantages from this SPT test, what are the disadvantages, what are the different precautions one need to take while carrying out this SPT test, and so on. We'll try to go through them. Let's say, for example, this is my ground. If I want to understand the condition of the soil which is there at a depth of, let's say, 2 meters below the ground surface, okay, so I want to know the corresponding SPT value of the soil which is there at a depth of 2 meters from the ground surface. So if SPT test is to be conducted on the soil which is there at a depth of 2 meters, so first what I should be doing is I should be making a borehole till that depth of 2 meters into the ground. So what should be the technique that I should be following for making the borehole into the ground? Means whatever is the suitable technique, it could be by augering process, or it could be by whatever mechanism by which you can make the borehole into the ground, you can proceed to follow that. Okay, so in general, for shallow depths, we prefer to go for what is called as your augering technique. In case of boreholes that are to be extended below the water table position, we prefer to go for wash boring technique. In case if you want to go for boreholes of relatively larger diameter, one will go for what is called as percussion drilling. In case if you want to make the boreholes into a very hard strata like rocky strata or maybe a very stiff soil, in such case we can go for your rotary drilling technique. So depending on the condition of the soil, one can go on to choose different type of technique for extending the borehole into the ground. Okay, let's say whatever is the technique that is available, I followed that. I made the borehole into the ground till my required depth, where I am required to perform my SPT test. Now, if I need to perform my SPT test at a depth of 2 meters on the soil, which is there at a depth of 2 meters, first I should be knowing how does my SPT test assembly look like? What does that it contain, the SPT test setup? So what we are going to be having is, we are going to have a kind of a tripod to which you have a connecting pulley or a guiding pulley, over which you are going to be operating a cable. And in turn, that cable on the other side, you will have group of people pulling that cable here. Okay, so on the other side of the pulley or the cable, you are going to have what is called as your hammer. It's a standard hammer of mass 63.5 kg, and this hammer in turn is connected to a guiding rod so that this hammer can slide over this guiding rod. It can be lifted with a sliding mechanism, where this guiding rod is going to guide the hammer in which direction it is going to be lifted, and so on. Because hammer should not be swinging, so it has to be properly lifted and released, properly lifted and released. And we are going to have to this guiding rod, we are going to have a kind of a collar which is connected. Okay, this is your rod, and to this collar again we are going to have some connecting rods. And to the bottom of this connecting rod, you are going to have what is called as your sampling tube. Okay, so this is your sampling tube. And here the type of sampling tube what is used in SPT test is what is called as split spoon sampler. It's a hollow cylindrical sampling tube, where that hollow cylindrical sampling tube can be split into two parts. Two hollow cross-sectional parts it can be divided into, and that's the reason why it is called as split spoon sampler. We'll be seeing that sampling tube, how does it look like, and so on. So now what we are going to be doing is this sampling tube. First, I should make my borehole till the required depth. The bottom of the borehole has to be properly cleaned in the sense it should not have any soil grains existing at the bottom of the borehole, whatever you have excavated, borehole which you have extended into the ground. So bottom of the borehole has to be properly cleaned. So at the bottom of the borehole, your sampling tube has to be properly placed. In turn, this at the top of this, you are going to have your connecting rods. Okay, so to this connecting rod you have your collar, and to this collar you have your guiding rod, and over this guiding rod you have your hammer which is in turn connected, and over here you have a kind of a nut or a ring system to which your cable is connected. Your cathode or your tendon is what is connected. Okay, this is your simple test setup what we are going to have. And as I said, you are going to have different types of hammers that are available. So depending on what type of hammer that you are going to be using, so each standard hammer what you are going to be using will have some standard mass. Okay, but here typically in the case of SPT test, that the so-called hammer what we are looking at has got a standard mass of 63.5 kg, and the corresponding standard free fall what we are going to be maintaining is 760 mm. So what we do is we lift the hammer, we release it, we lift the hammer, we release it. So the hammer of 63.5 kg is lifted in the upper direction by pulling your cable. So in fact the hammer is raised, and you have a kind of a locking mechanism. So once the hammer is lifted by 63.5 kg, your lock gets released, and the hammer comes and hits your collar. And once the hammer comes and hits the collar, and what is the standard free fall height from which the hammer is going to fall means it is 76 centimeters or 760 mm. So from that standard free fall height, the hammer is going to hit your collar. When when you are hitting the collar, then in turn the connecting rod which is connected to the collar is getting pushed in the downward direction, and in the process the split spoon sampler is getting penetrated into your ground. Okay, so penetrated, we are going to see that your split spoon sampler starts getting penetrated into the ground. Okay, so now what is that ultimately we are trying to look at in this SPT test is we are going to find out the number of blows which are required to be given for 1 feet depth of penetration. Okay, so ultimately what we are trying to determine from this SPT test is we are going to find out how many number of blows that are to be given for your split spoon sampler to get penetrated by 1 feet depth of penetration. So 1 feet depth of penetration means it is 30 centimeters. Okay, so for 30 centimeters depth of penetration of your split spoon sampler, how many number of blows that are to be given. So those number of blows we are going to be counting, and that particular number of blows is what we are writing it as here n value that we are going to be getting from your SPT test. So ultimately from the SPT test, what we are going to be determining means the SPT n value. Okay, so it's nothing but we call it as your SPT value. N indicates the SPT value. So based on this SPT value, one can go on to find out the various other correlations or the properties of the soil, as like earlier I have discussed about. Okay. So let's quickly understand what are the different components that I have talked about and how the test is conducted. So as I mentioned, like for every we are going to understand how many number of blows that are required to be given for 1 feet depth of penetration. But exactly while conducting this test, what we try to do is, let's say I'm going to, from the bottom of my borehole which I made, I'll try to understand a markings of 15 centimeter, another 15 centimeter, and another 15 centimeter. Sir, you said only 1 feet depth of penetration, but you have marked 1.5 feet depth. Why? Because what happens when you are making the borehole is the soil which is more or less there at the bottom of the borehole in this particular region, the soil whichever is going to be there would be mostly in a disturbed state. Why the soil at the bottom of the borehole is going to be mostly there in a disturbed state? Because while extending the borehole, you are trying to cause the shearing in the soil for removing the soil out from the ground. So in the process, the soil which is there at the bottom, nearer to the bottom of the borehole, okay, soil just there below the bottom of the borehole would be certainly there in a disturbed state. That's the reason why for first 15 centimeters depth of penetration, the number of blows whatever you have counted. So ultimately what I am going to be doing here is I am going to mark 15, 15, 15, 3 15 centimeter interval markings on my connecting rod. Let's say at the ground level, I'll just try to make markings on my connecting rod for 15, 15, 15 centimeters on the connecting rod. Okay, so if I say this is my connecting rod, this is a position at the ground level. So this is my ground level, 15 centimeters marking, another 15 centimeters marking, and another 15 centimeters marking on my connecting rod. So what I am going to do is, for first 15 centimeters depth of penetration, I'll count number of blows. For the second 15 centimeters depth of penetration, I'll count the number of blows required. And for the third 15 centimeters depth of penetration, I'll count the number of blows required. But however, I am going to discard this number of blows required for the first 15 centimeters depth of penetration, for the reason that the soil which is encountered during that first 15 centimeters depth of penetration is assumed to be mostly in disturbed condition. So that's the reason why the number of blows what are given for the first 15 centimeters depth of penetration of the split spoon sampler into the ground, so that number of blows are assumed to be discarded. Those number of blows you are not taking into consideration. Then which number of blows you are taking into consideration means for second 15 centimeters depth of penetration and for third 15 centimeters depth of penetration. So total put together, the remaining 30 centimeters depth of penetration, whatever is there after the initial 15 centimeters. So for that next 30 centimeters depth of penetration, what are the total number of blows that are required to be given? So that we are going to be calculating as your SPT n value. So here I am simply writing it as SPT n value is nothing but it is equal to N2 plus N3. N2 plus N3 indicates here, according to my understanding of whatever I have discussed here, nomenclature which I have followed, N2 here indicates the second 15 centimeters depth of penetration number of blows required, and for the third 15 centimeters depth of penetration the number of blows required, which will give me a total of, for 30 centimeters depth of penetration, how many number of blows that were required to be given for your split spoon sampler to get penetrated into the ground. Okay, so that's what ultimately we are going to be calculating from this SPT test. So let's quickly go through each of those, whatever we are trying to talk about. So we are going to be using typical type of equipment, whatever is suitable for that soil condition for making the borehole. And this is how typically your split spoon sampler is going to be looking like. Okay, so a hollow tube which can be split into two parts. Now, why you are using a split spoon sampler means there is an advantage of using the split spoon sampler, because when you are pushing this sampling tube into the ground, what is happening? The soil is getting collected into the hollow region. And once the soil is collected into the hollow region, and once you ensure that your required 1 feet depth of penetration into the ground is completed, we say SPT test at that particular depth is completed. So then what we are going to be doing is we take out this sampling tube out of the ground, and then we remove the soil which is collected in that sampling tube. Mostly, or rather I could say the soil which is collected in the sampling tube will be in disturbed state only. Okay, why do we say it is in disturbed state? Because the area ratio of that particular sampling tube is going to be greater than 10% for that split spoon sampler tube which is used in our SPT test. Okay, so but however, the soil sample which is collected in that sampling tube, which is still there in disturbed condition, can be used for understanding how is the condition of the soil, what type of soil is there, what is the depth of the soil strata, and all such information can be understood, and subsequently your index properties can also be determined from that disturbed soil sample what you have collected from the split spoon sampler. Yeah, this is your dry wet assembly. So this is your complete tripod setup. Okay, so this is what is called as your cathode or your cable, which is going to be used for lifting your hammer. Okay, a hammer of 63.5 kg is used with a free fall height of 76 centimeters. Cathode is nothing but it's the cable what you are connecting there, in turn which is connected to lift your hammer there. So we are going to have different types of hammers that are available. Okay, so typically it depends on the SPT n value what you are going to be talking about, what you are trying to determine. Depends on the type of hammer what you have used, because some type of hammers what we are going to be using there is going to impart only 30-40% of energy what you are trying to transfer. Okay, ultimately on the split spoon sampler, how much of the energy is getting transferred out of what you have applied? Is it 100% of the energy is getting transferred onto the split spoon sampler while pushing it, or only some percentage of the energy is only getting transferred? So it depends on the type of the hammer what you are going to be using there. So we have got typically different types of hammers available. So let's say this is one type of hammer which is called as a safety hammer. So where this hammer, whatever, look at here, this is the hammer what I am talking about, which is connected with a setup of what is called as a guiding rod. So your hammer cannot swing. So it has to move only over the surface of that guiding rod while you are lifting it and dropping it. So it is found that this particular type of hammer approximately delivers only a 60% of the maximum free fall energy. If it is freely allowed to fall, 100% of the energy was supposed to be getting transferred. But however, because of this guiding system and because of the resistance between the guiding system and the hammer, which is relatively in contact, it's assumed that only 60% of the maximum energy is only getting transferred onto your split spoon sampler, because of which that 60% of the energy, because of which only your sampling tube is getting penetrated into the ground. And you have got typically another type of hammer like a donut hammer, in which only a 45% of the maximum energy, free fall energy, is getting transferred out of the 100% what you are trying to impart onto your split spoon sampler. And we have also called as automatic hammer, which is completely an automized setup, computer operated. Manually, we are not going to be operating this setup. Okay, so in this kind of hammer, we are going to see that 95% to 100% accuracy is what we have got in transferring your energy onto your sampling tube. So to start with, how do we conduct this SPT test? Means first we need to make a borehole till the required depth. At whatever depth you want to perform your SPT test. Sir, in a particular site, is it only at a one depth we are going to make or we are going to perform the SPT test? No. At whichever depth you want to perform your SPT test. Let's say, for example, first I want to know the SPT N value of the soil which is there at a depth of 2 meters. Then I want to know the soil SPT N value which is there at a depth of 4 meters. So what I can do is first I'll perform the SPT test at the depth of 2 meters. Once the SPT test for the soil at 2 meters depth is completed, then remove your test setup. Test setup in the sense, not the complete test setup. The sampling tube is going to be taken out. And whatever the borehole that you are required to extend, because next where you want to perform the SPT test, at 4 meter depth, if I want to perform my SPT test, then I'll continue to extend my borehole till the 4th meter depth. Now, once the borehole is extended till the 4th meter depth, then I'll place back my sampling tube again, split spoon sampler tube with the complete connected system, and then I'll perform my SPT test. Once the SPT test at 4th meter depth is completed, then take out your sampling tube, then extend the borehole till the next depth where you want to perform your SPT test. Okay. So one thing what we need to understand from this SPT test is, this SPT test will not give the information regarding the soil which is there throughout the depth. Okay, we are not going to find out the SPT value of the soil continuously. Rather, at a regular intervals. At regular intervals in the sense, typically SPT test is conducted if at all you want to find out the SPT value of the soil. So SPT value of the soil can be determined only at some regular intervals of depth of 1.5 to 2 meters. It means first, if the SPT test is conducted at a depth of 2 meters, then next SPT test has to be conducted only at a depth of 3.5 to 4 meters only. And next SPT test has to have another interval of 1.5 to 2 meters again, because you are while performing the SPT test, you are seeing that your split spoon sampler is getting penetrated by 315 centimeters interval, in the sense that 45 centimeters depth of soil has already been collected into your sampling tube. So that's the reason why you should carry out your SPT test only at a regular intervals of 1.5 to 2 meters. You cannot continuously get the SPT value of the soil throughout the depth. Only at regular depths only you will be able to get your SPT values. Okay, so first step is to make the borehole into the ground. Okay, so typically a borehole of diameter 100 to 150 mm is what we are going to be making into the ground. Ultimately, what I should understand is the size of the borehole should be at least 10 mm greater than that of the diameter of the split spoon sampling tube what you are going to be using there. Okay, that is something what you should be carefully understanding. So as we have said, this SPT test is more suitable in the case of your cohesionless soil, but however, it doesn't mean that you cannot perform your SPT test for other type of soils. Even for cohesive soil, you can perform the SPT test, or for cohesionless soil also, you can go on to perform your SPT test. Okay. But in case if you are performing the SPT test in sandy soil deposit, you should be using what is called as a casing while making the borehole into the ground. Okay, so why the casing is required? If the casing is not used while extending the borehole into your sandy soil deposit, or even in your soft soil deposit, so the surrounding soil gets collapsed, you are going to see a cave formation happening into the borehole region what you have extended. So next is driving the casing, so that if this is my borehole what I am trying to look at, if this is a borehole what I have made into the ground, so try to push a casing tube, hollow cylindrical tube, steel tube into the borehole, so that the soil from the surroundings will not get collapsed into that particular borehole what you have made, particularly in the case of your cohesionless soil, and even in the case of your soft soil deposits. And next, once the casing is provided, one thing what we should understand is the depth to which the casing has to be extended should not be beyond the bottom of the borehole position. I repeat, the depth till which you should extend your casing should be over and above the position of your bottom of your borehole. If the casing is pushed beyond the bottom of the borehole, then what is going to happen is, while this SPT test is performed, your penetration of the SPT, penetration of the split spoon sampler will have an impact because of the casing what is driven below the position of your borehole. Because if the casing is pushed below the bottom of the borehole, then while pushing this sampling tube into the ground, the soil which is coming in contact with this sampling tube will try to sometime move laterally into the soil sampling tube or away from the soil sampling tube. Okay, so if the particles are trying to move away, if the casing is not allowing the particles to laterally get displaced, obviously casing will not allow the soil particles to laterally have displacement, which in turn indicates that the resistance offered on the sampling tube is going to be more. In such case, you will be required to give more number of blows onto your sampling tube to cause the required depth of penetration. So you have to be very careful when you are using any casing inside your borehole what you have made. Okay. So next, you should have a proper assembling equipment, as I have told you, like your sampling tube to be connected to your connecting rods, on top of which you have what is called as a dolly or a platform, on which you have your guiding rod, over which you have your hammer existing. So that complete test setup has to be properly assembled, where the hammer what you are going to be using there should be of a standard hammer of 63.5 kg with a free fall height of 76 centimeters. And we should have some markings done on your connecting rod with a piece of chalk or whatever in 3 successive intervals of 0.5 meter. Okay, so we are going to see for first 15 centimeters depth of penetration, how many number of blows were required, next 15 centimeters, next 15 centimeters, and accordingly in 3 successive intervals of 15 centimeters each, we will count how many number of blows are required for causing the penetration, and that first 15 centimeters depth of penetration of the sampling tube, the number of blows what are required, that data will be discarding, and for the second and third intervals of 15 centimeters, how many number of blows that you were requiring. So we'll be adding both of them together to say what is my SPTN value that I have got for 1 feet depth of penetration of your split spoon sampler. Okay, this is how typically your complete test setup is going to be looking like. So at the bottom of the borehole, you are going to be placing your sampling tube, and by applying your impact load from the top, you are going to be pushing your sampling tube into the ground for a depth of 1 feet penetration. So what we are going to be ultimately calculating is your penetration resistance. Penetration resistance means when you are applying the load from the top, how much is the resistance offered by the soil. So we are not directly calculating in terms of the resisting force there, but rather we are calculating in terms of the number of blows that are required to cause the penetration into the ground. So higher is the number of blows, it indicates the soil is relatively stiff or soil is relatively strong. Lower is the number of blows required for that so-called 1 feet depth of penetration. The condition of the soil is relatively loose or relatively soft. That's all what we can understand regarding the condition of the soil, depending on your SPTN value, what you are going to be getting there. First 15 centimeters depth of penetration is what is typically called as seating drive. So where the number of blows corresponding to that first 15 centimeters is discarded, assuming that the soil condition there might be in what is called as a disturbed state. So what we are ultimately looking at is the next 15 centimeter and the subsequent 15 centimeters depth of penetration. Total put together is 30 centimeters depth of penetration is what we are going to be looking at. In the process, now how this SPTN value we are going to be calculating, as I said, so we are going to be calculating the SPTN value. Okay, so let me write it here as N2 plus N3. Now, while performing your SPT test, you might come across with some difficulties. Difficulties in the sense there could be some issues where, which we are going to be encountering. If the number of blows for 15 centimeters drive in the sense for 15 centimeters penetration, number of blows required, if they are exceeding 50, I repeat, if the number of blows required for 15 centimeters depth of penetration, because we have marked 15 centimeters interval depths of penetration. So for 15 centimeters depth of penetration, if the number of blows required is more than 50, then we should consider that the SPT test cannot be performed on that particular soil. Okay, so we are going to refuse to perform the SPT test on that particular soil condition, and we say we are not going to continue the SPT test on that particular soil where the SPT N value is coming out to be, or rather the number of blows what are required to be given for 15 centimeters depth of penetration, the number of blows required is more than 50. So we stop the test and we say at that particular depth SPT test cannot be conducted. Test shall be made at every change in stratum or at intervals of not more than this is 1.5 meter. So whichever is less. So what we said is at regular intervals of 1.5 meter depth, we can go on to perform the SPT test. But however, whenever you encounter that there is a change in the soil profile, when you find there is a change in the soil strata, so wherever there is a change, you can go on to continue to perform your SPT test. So whichever is earlier. So whether you have a change in soil strata immediately coming or 1.5 meter depth is immediately coming. So whichever is less, so accordingly at that depth you can go on to perform your next SPT test at that location. The intervals may be increased even to 3 meters. Okay, so as I told, like if SPT test is performed at this depth of let's say 2 meters, at next depth of 3.5 meters, we said we will perform your SPT test, and next at 5 meters depth position, we are going to be performing the SPT test. But however, you can go on to perform your SPT test with an interval of what is called as even up to 3 meters. So this interval between the previous SPT test position to the next SPT test position can also be even 3 meters. But however, within this depth of 3 meters, if your vein shear test was conducted at some particular depth position, somewhere in between this 2 meters to 5 meters position, somewhere in between this depth position, if you have performed your vein shear test simultaneously in the same borehole, along with your SPT test, you are also making use of that borehole for continuously performing your vein shear test at different depths. So in such case, your SPT test can also be even conducted in that soil deposit at an interval of up to 3 meters also. The entire sampler may sometimes sink under its own weight whenever you need not sometimes apply what is called as your blows also. Just because of the self weight of the sampling tube itself, there could be some certain situations where the sampling tube can completely get sinked into the soil. That so-called 1 feet depth of penetration or whatever you are talking about, without even giving a single blow also, you might see the complete penetration of your sampling tube. That could happen because the soil is very, very soft in such particular condition. So in such case, it is not possible to conduct what is called as SPT test on such soil deposits. So under such conditions, it may not be necessary to give any blow to the split spoon sampler, and the SPT value should be simply indicated as 0, because even without giving a single blow, your complete split spoon sampler is getting penetrated into the soil strata there. So now, once the SPT test is conducted at some particular depth, as I said, once the SPT test is said to be complete at that particular depth below the ground, so we take out your sampling tube, and the soil which is collected in the sampling tube is going to be properly removed, and that soil has to be properly sealed in a polythene cover or in any container, so that the natural water content, the field moisture content, do not get changed. Okay, so bring the sampler or the sampling tube to the surface and open it. Remove any obvious contamination, maybe some grass or maybe any organic matter that you find which is coming in contact with the soil. You can just simply remove it. Carefully scrape or slice along one side to expose fresh material and any stratification, because we had a split spoon combination there. So properly push one portion of your half of the split spoon sampler in one direction, so that you will have a clear visualization of how the stratification of the soil is there, and what is the length of each soil strata, what is the composition of the soil, what is the color of the soil at different depths. All such information can be properly understood by looking at that particular soil sample which got collected in your sampling tube. So remove the sample and wrap it or seal it in a plastic bag to retain the moisture, so that once you seal your soil sample in a polythene cover or in a plastic bag, you can more or less ensure that not much variation in the moisture content takes place before the soil sample is carried from the field to that of your lab for subsequently determining the natural water content present in that particular soil.